if you have the square root of m to the 15th over 121 m to the third, let's say, and you're asked to simplify. So square root of 121 is 11, and so it's in the, notice how it's in the denominator, right? So when you take it out, you have to put a 1 so that the 11 could be on the bottom. Now with the m's, you have m to the 15 over m to the third. Well, remember when it's a quotient like this, m to the 15 divided by m to the third, you subtract the powers. So this becomes m to the 12th. 15 minus 3 is 12. Well, the square root of m to the 12th is m to the 6th. So it's m to the 6th over 11. No more radical because you've simplified it. You took the 12, m to the 12 out as m to the 6th. Okay? Another problem. Let's see. You have to be able to simplify. We already did something like that. Simplify a to the negative 10, b to the 15, and we're going to raise it to the negative 4/5. Okay, so and the instructions are to leave your simplify it and leave all exponents as positive exponents. No negative exponents in your answer. That's the only rule, or that's the only condition they want you to follow. So no negatives in your exponents, all positive exponents. So again, we're going to raise to this power. So when it's power to power, you multiply. So we're going to multiply the negative 10 by the negative 4/5, and then the 15 by the negative 4/5. So that gives us negative 10 times negative 4/5. That's going to be positive 40 over 8. So 40 over 8 is 5. And then right here, b to the 15, so 15 times negative 4/5, that's going to be 60 over 5, so it's going to give you negative 12. Okay, so then the b to the negative 12 has to move, so you end up with a to the 5th over b to the 12th, just to make it positive exponents. Okay, and that's the answer for that one. Okay, something else that you guys have to be able to do is change a radical to a rational exponent. So let me give you a few examples of that. So it could be, let's say, 5th root of 10 to the 3rd. So this would just be basis 10. The exponent is 3, the power is 3, and the root is 5. And that's all you do. Okay, another one, 10th root of 9 to the 4th. So this would be 9 to the 4/10, which you could reduce if possible, so 9 to the 2/5. So that would be the final answer. Okay. Something else that you guys have to do, you have to be able to simplify something that's in radical form. Let's say 8th root of x to the 3rd over 8th root. Let me change this one. make it 4th root of x to the 5th. Okay, and so I think the easiest way you can do this is change it to rational exponent. So this would be x to the 3/8 over x to the 5/4. Okay. 5/4 is bigger than 3/8, so I'm going to move this one down. And so that's going to leave me with 1 over x to the 5/4 minus 3/8. Because remember, positive 3/8 in the numerator becomes negative 3/8 in the denominator. So then, to simplify that, let's see, that's 1 over x to the 10/8, that's 5/4, minus 3/8. So the final answer would be 1 over x to the 7/8. You can leave your answer like that. Okay. Another one. Let's see. That's dividing. So in multiplying, 4 to the x, 5 times 3 to the cube root of x squared. So when you're multiplying, again, I'm going to change it to x to the 5/4 times x to the 2/3. So we know that when we're multiplying two numbers with the common base, we add their exponents, we add their powers. So 5/4 plus 2/3, common denominator is 12. So then that becomes x 5/4 in terms of twelfths becomes 15/12. And 2/3 in terms of 12s becomes 8/12. So now you have x to the, let's see, 15 and 8 to the 23rd 12th. And you could keep your answer like that, or if they tell you to write it in radical form, it's the 12th root of x to the 23. You could also write it like, okay, there are 23 over 12 is 1 and 11/12, right? 23 over 12. So I can take out an x, and then there are still 11 left over. Okay? And so either one of these is fine. Okay, so now I'm going to move on to solving equations. So I'll start off with square roots. So let's say we have, I'll start numbering with 1. The square root of x plus 3 plus 5 equals 2. So the first thing we want to do is eliminate, or isolate, I should say, the radical. So to leave this part by itself on the left side of the equation. So I'm going to subtract 5, and so I get the square root of x plus 3 equals negative 3. Well, the square root of a number is not negative. Okay? Had this been a cubed root, then we would keep going, but this is a square root. The square root of a number, it cannot be negative. So this would be no real number solution. Okay, and that's all there is to that one. Number 2, if you have, let's say, x, so like if it were like, let me just go back and do this. If it had been cube root of x plus 3 plus 5 equals 2 instead, then you would do the same thing. You'd subtract the 5, cube root of x plus 3 is negative 3. Then we would raise both sides to the third power. And so you would have x plus 3 on the left, negative 27 on the right, subtract 3, so x would be negative 30. Okay, so notice the difference. With cube roots, you could have a negative on the other side because negative 3 to the third power is 27, so that number exists. Okay, whereas with the square root is not a negative number. Another problem. Okay, so for number 3, we have the square root of 8x plus 9 equals x. So the square root is already isolated. It's already by itself. So what we're going to do next, oh, and by the way, I've been writing these all with radicals, but it could also show up like this. It's the same thing. So this would be to the 1/2 equals x. Okay? So remember, you need to know how to approach that too. So it's going to be square both sides. And so then we have, on the left side, we have 8x plus 9. On the right side, we have x squared. So because the x squared is positive on the right side, I'll just move the 8x and the 9 to the other side. Okay, so now I have, that's gone. So I have 0, x squared minus 8x minus 9. So we factor, and so we get x equals 9 and or negative 1. So we have to check our answers. Okay, we have to check our answers. So go back to the original equation and plug in the 9 and see what we get. So 8 times 9, so I'm going to check this one first. 8 times 9 plus 9, and I want to take the square root. So 8 times 9 is 72, 72 plus 9 is 81. The square root of 81 is 9. So 9 equals 9. That works. Then we check negative 1. So x equals negative 1. 8 times negative 1 plus 9. Well, this gives me 1, the square root of 1. But then on the other side, I would have to replace that x with a negative 1. So square root of 1 does not equal negative 1. So this one is not a solution. This one does not work. So the only answer is x equals 9.